the first question may be, Oystein, who is the owner of the project?
The owner of the project is Statens Vegvesen, the Norwegian road authorities.
Sigmund, even knowing then you are here today not representing the owner, I think you'll be able to answer these questions. Does that mean the owner wanted to do this project this way? Do you know who had the original idea?
Well, obviously the owner is instrumental in deciding whether to use BIM or not. So sure the project owner is the one that wanted it. For the original idea, it's in particular this project is project owner and the mandatory sort of decision in Statens Vegvesen for using BIM in all their projects. But originally, the idea is a little bit more complex, isn't it? Technology has been there for a long time. And then we have developed in Norway through some organizations like the Statsbygg, which is the Directorate for Property and Constructions in Norway, making BIM mandatory in all their projects back in 2010. And then we had Terminal 2, which is the main airport in Norway, which made use of it, BIM in 2009, and so on. So, the original idea is somehow just developed here in Norway, from constructions and over to infrastructure.
Then we have PNC Isaksen as contractors. Then we have Armando, Rito as designers, SWECO as detailers, and Statens Vegvesen as the client. And what about the approvals?
Yes. What about me?
Yes.
Yeah, it's a governing body for all design of bridges and other bearing structures in Norway for national and county roads. So this is a governing body, and then you have Statens Vegvesen, which is the client for building these projects. So yeah, that's my role in this.
Okay. Now it's absolutely clarified, and we did it right. Tiago, is this an alliance, or are you all tied to the client?
No, this is a 100% design and build project. And so we are all part of a team that is led by PNC, which is part of the Austrian Group 4 that signed the contract with Statens Vegvesen, the client. And since we haven't addressed it yet, and I think it's important also to address it, the third-party control. I think it's also important to address it because it was also a key player on this project, not only from the technical part, but also controlling the 3D model. It was very, very easy to communicate between all parties. And I think that we still have a lot to show for the next projects and to improve. But I think that it's worth mentioning that because they had also an important role.
Maybe Oystein, is there anything special about the Nordic culture that influenced this project?
It's a bit hard to say, but it's a small country, and all the Nordic countries are relatively small. So knowledge is shared fast. We got a high level of electrification, or what do you call it? Data and knowledge, and high level of technology. So I think that has been very helpful. And then you have some visionary people like Sigmund and his team that has opened up for the approval process. And that's the most important thing, I think, because the technology, as you mentioned earlier, has been there for a long time. So once Vegdirektoratet was opening up, then we as designers were ready to go, and then you're sort of half forcing the people building it to use this technology as well.
This next one is for Tiago. How did our Portuguese culture adapt to this way of work?
I think we adapted quite well, but of course. So our first reaction was strange because the team asked, do you really think we can do this without no BIM experience? So I just kept silent for a couple of minutes, and I answered, I don't know why you say that, because we have designed so many bridges like this, and we all have seen them being built. We just have to find a good way to communicate with the guys who are doing the modeling.
The next one, if you have any good or bad episodes, in this case now to do with the culture, but looking into the construction site workers.
In fact, I think I have a funny episode to tell that I will never forget. At the time I was worried about it, but now I can say it's really funny episode. The first time I went to site, and first foundations were just starting, and there was not so many activity. But what dazzled me was that everything was just keep asking, where are my drawings? Where are my drawings? Which so this of course worried us a lot, because we can feel their frustrations. But even though there are still a lot to do and to improve, it's good to see that PNC and the workers have found ways to overpass this initial frustration, and they are now really exciting using the model.
I don't know, Oystein, if you want to share something.
I think the thing I'll remember always is our first meeting with Tiago and the designing group, because he and his team has so many years and so many bridges of experience, and doing a model of this, you need a young team of engineers that know parametric design. So in our first ICE meeting, we were standing there, and I think I was the oldest one by maybe 14 years or so. So you have all these young, very talented people knowing programming and parametric design, but I could see Tiago was a bit worried. He thought the average age was was maybe 20 years too low. But yeah, so that's a phase I'll remember forever.
Elsewhere, the approval process is mainly 2D based. So Sigmund, how on earth did you guys start developing the 3D model-based approval process? How many models you already approved using this method? Were you guys bored when you come along with this idea? Let's start approving bridges just on 3D based model.
We weren't bored, but basically what happened is back in 2015, we made the regulations of how to design bridges in Norway, allowing for BIM to be used. For a part of a time after 2015, that regulation or allowance wasn't touched. In 2017, we met this project owner that wanted to try BIM in his project, and he asked us and said to us actually that if we were the reason, and verification were the reason why we didn't develop in BIM in Norway. So answering that question was, yeah, well, we allow for BIM to happen in design, thereby we need to allow it for approval. So it were very much not by choice, it was just that we needed to just adapt when we're not. Then the question when the project owner wanted to deliver on BIM, the question became, how? So that's basically where we started. We just collaborated with the project, trying to figure out how we could do this, how we could both design and as well check for things, and started with a couple of principles during the fall of 2017. And then by 2018, we had the first approved bridge for building in Norway. And from that point on, we have now about 150 structures modeled and approved for erection. That's cool.
That's cool. 150, you say. And as far as I know, the law itself didn't change, right? So do you mind to clarify that?
Yeah. So as I said earlier about the technology has been there for a while in Norway, and we used it in big projects at the main airport in 2009. So while we were writing the regulations back in 2014, 2015, we slipped in this a little paragraph saying the 3D digital information modelings are allowed in bridge designs in Norway. So this was always a choice there. So when the project owner came to us and asked if they could deliver the model or try to use them, we had to say yes, because as it's allowed for design, it was we needed to adapt for the approval process as well. We didn't actually change the law because it was already in there, but we needed to adapt it and develop it. So this is where the principles came in, where we saw a basic and a major principle was that the detailing of a model needs to be the same detailing level as demanded for drawings. That was one big principle. Another principle was that all the information that were developed needed to be incorporated to the model, or you should strive to incorporate all the information that you develop during a design phase into the model. And for the regulation part, that was fairly easy, isn't it? Because you just take out drawings from your regulations and just put in models, and then you have basically some adapted laws or regulations.
Do you do markups into the models, or then you send to the documents when you're doing all those remarks and so on?
The approval process. Well, the way
Yes.
the way it functions is that we have this collaboration tool, which we sort of communicate the documentation back and forth from the project and to our organization. So what happened is that the model from the project, they have a live model, they mirror their model, they send it to us through this collaboration tool in open source. So we have this mirrored model. Calculations are not incorporated into the models. Calculations is still in the report. But basically all the control besides the calculations are in the model. What we do then is open the mirrored model, and we do our comments directed to the objects that we have a comment on, or that needs to be rectified or whatever. And when we're done with all our checks, we export what's called a BCF format, or BIM collaboration format, and we send it back to the project. The project then have the live model. Our comments are linked to the objects, and they can import the BCF, the comments into their live model. They do their checks and revise their objects and mirror the model back to us again. And so on it goes in a sort of a loop until all the checks are done and we can approve the model.
Are you okay into sharing what you guys are learning all these years that implementing this 3D model-based process?
Yeah, of course. What you learn about this process is that collaboration is key, isn't it? It's a different way of working, and the way you sort of binding the designer with the contractor and the governing bodies and all these things. So of course collaboration is key, and thereby we share happily. It's the most important part of this development is that we are collaborating with each other. So yeah, I've kept presentations both in Denmark and Sweden, and if anyone asks, I will say yes.
Cool.
And Sigmund says by sharing, it's relatively small, a small environment of bridge engineers in Norway, of course. So when someone comes up with a new idea and a new way of doing things, it's inspiration for all of us. And I'm sure many others too, we're very eager for other countries to start doing this, because as everything is technology, it's very easy to adopt new ways of working. So inspiration from other countries is very much welcome. So we're really looking forward to seeing other ways of doing it, because we see a tendency to everyone doing the same, which could mean that we're doing the right thing, but it could also mean that we lack inspiration from others. So we're eager to see what other people come up with.
Makes sense. Yes.
Yeah, there's a slightly alternative way going on in Finland, that we're actually doing the inspection and the approval processes based on a BIM model, and that's the only official document, but we're also going to create like these very light work drawings, but they don't need to go through the approval processes. So that's actually making our workflows much faster already, and we need to produce less drawings significantly.
Now I want to go back to Tiago, right? So I think Oystein said already something interesting about your reaction when you enter into that room the first time, and then you come across with the idea of drawing-free project. So do you mind to tell me what crossed your mind when you realized, oh, this is a bridge as usual, but a complete different way of doing it?
What crossed our mind? Well, we knew from the very beginning that this would be a huge challenge. And like Oystein said, on the first talk that we had, I just knew it from the start that this would be this wouldn't be a piece of cake. Not because this haven't been done before, it's because we have seen it a lot of times, but in a more, I would say, simple way of showing the information, right? And when you transfer this to a model, you have to include everything in the model with the detail, and this requires much more detailing and much more, would say, much more engineering, even to transform it and to foresee everything that the workers will have to do at site.
And which were the constraints or the main constraints that led to the final bridge solution for the project?
Well, Randselva bridge, it's in fact a very good example why each bridge should be seen as unique, and it has its own history and importance. The crossing is located in a very asymmetric valley with a major constraint, geotechnical constraint, with a steep slope with 80 meters height of sand on the west side of the valley. And there was also a great need or a wish for the client to reduce the deck height. And all this, together with other functional needs, like the railway crossing and also a parking place, and also a local road that gives now access to the new Schistefos Museum, all of this determined and defined the final solution.
Is that house that I've seen on that picture, that red house, is going to stay there?
Yes, it is.
Yeah, oh, nice.
The local access that when you in the future parking place will have a street that connects to that house. Yes. Right.
All right. Okay. And what can you say about the complexity of the bridge solution and the way it has influenced the model-based project?
Well, I would say that the best to start for a project like this would be a straight bridge. Simple straight bridge with a regular geometry. For example, like SWECO did so many times on the bridges for the E6 and for the North, which was, I would say, decisive for the success that we are having now, because it was a fantastic preparation for what we are doing now. And Randselva bridge, we have to understand that it's a curved bridge with two different, clear different types of structural systems. The free cantilever part with large spans on the west side, and the 60-meter spans on the east side. Then demanding constraints, geotechnical constraints again, required 4 different types of foundations. So we can say that in this bridge is a clear example where everything is mixed together, and I guess we can call it was quite a challenge.
So detailing, Rasmus, we know that is a pan-European team and is working on the models, and we all know that the technical model sharing is being a very reliable tool to have more than one person working in the model. But the question is to do with the Grasshopper scripts. So were those scripts controlled by just a few and very well controlled? How did you implement that? The team implemented this access to the scripts, Grasshopper scripts.
That's a great question, and there was a rather simple solution. So basically, there's a function inside Grasshopper which allows you to write this GH data file, which actually allows you to connect multiple scripts together. And our solution was just so simple that I think we were 4 people working at the same time. So we had a bunch of scripts each other. Maybe we had 3 per worker, something like that in the end. And we just connected these scripts together with these sort of transfer files, GH data files. So that way we could just work in real time in our own Grasshopper scripts, which actually worked pretty well. So I don't think there's been any negative effects of that. And thanks to internet connections, we could share those changes like immediately.
So right then, so those 4 or 5 programmers, let's say engineers, they were developing the scripts. So then they were the main responsibles to load that into the model and then upload that to the cloud, right?
Yeah. Okay. So we shared information with each other, but we were all responsible ourselves for what we were doing. So the geometries and the data we made, we put that into the single Tekla model ourselves. So, but we just needed to share geometry between each other. Like, for example, I was in charge of the superstructure mainly. So basically, everyone else, of course, needed the superstructure geometry for something. Then I needed to share that data to everyone in a simple format, in a ordered format.
Mm. And in your opinion, do you think that 3D model, BIM model, of course, can beat a 2D drawing in quantity and quality of the information? What is your opinion on this?
Well, I think it's very, very obvious that I think that it can beat it because you can only reach a certain level of information in a drawing until it becomes too full of stuff that you can't just read it. And in a drawing, you need to play with different types of line types, line weights. Someone wants a specific font, and if you just put too much stuff into a drawing, it can become useless. But I would argue that a BIM model basically has no limitation on how much information you can put into it.
Okay, I've been there, and I agree. But just for your information, this can be used against you in a court of law. All right, so you just answered. So now, honesty above all, please. Anyone tell me that none of you ever drafted a drawing to help the guys on site? Come on, I want the truth, please. Just one drawing. Come on, a sketch just to help the guys.
Yeah,
I made sketches for Tiago.
I think we prepared for the drain pipes. Then I did a 2D sketch of how we thought it would be done. And what happened to that sketch later on, I'm not sure. But then we've replaced in the model 3D objects based on the comments from that sketch. So we have some drawings, but I'm sure they could build the whole thing just based on on the model.
Yes, but in the end, you set that drawing on fire, right? So you got rid of the evidence. So if you did that, if you did that, it's okay.
I got rid of the evidence, Oystein. You thank me later.
So many times that we are creating, we go and draft something and then go back to 3D. I remember in the past when I was starting to do the bridges, so many sketches I would do in 3D. And I don't know, I think my first 3 years, I never understood very well how an abutment was working, right? And I always did the drawings in 2D, but there were bits of the abutment that I was still fighting to understand how is that those connections working, and not talking about rebar. Rebar, it's even more complex, but by then I was already very experienced, so it was much easier here in UK.
Since we are talking about the relation with the workers and sketching for the workers, not between ourselves, right? Who did the design? I guess it's we have to say it's for the most complex zones, some plots of the model are being done to help the more complex zones understand those enormous quantities of layers of reinforcement. And PNC has is working on the model, rotating the model to do some views and some plots with views that help the workers understand on site how to assemble the ring.
So one thing I remember was first time we met the PNC team. I was a bit nervous because I didn't know them yet, and of course you can build a model that's absolutely correct and that gets approved, but what's the most important in the end is that that's transferred to the people at site. So having very qualified people at site that's going to use the model is essential, and meeting the guys, including Victor Rybus at PNC, I was quite nervous meeting them, but they have really done honor to the model, and they do fantastic things that we didn't even think about. So we were very happy and very lucky on this project to have really good people at site.
I need to go back to Rasmus to ask one more thing. We know that the technology evolved immensely.
Yeah.
So the question is, Rasmus, so limitations of the software for things that the team wanted to do, but there were some limitations and things that they need to be developed further.
I'm not sure if there are any like hard limits, since we have the resources and capability to code stuff by ourselves. But I think we had some issues with creating the some of the cable geometries at first, because the tools didn't support creating like accurate polybeams, which are like lightweight objects in Tekla, and we had to use like these items, which are basically a lot heavier objects, and sometimes they can't be edited in Tekla. So there were some issues with those, but otherwise than that, there's really like no limitations to what we could do. So yeah, actually we even fixed that part later on, because the tools for the Tekla link developed by Sebastian Lindholm, big thanks to him, evolved a bit still when the project was going on, and we could make a little change to the cable geometries so that they are actually like native Tekla geometry.
Yes, we are entangled here with thoughts, because that was exactly what I was going to say. That I remember very well that Sebastian developing the polybeam capability inside the Grasshopper link for Tekla structures. right? So, and yeah, very well.